All right, I ran out of time, so here we are picking up. I've got my b sub y now, and I'm adding my a sub y and my b sub y, in other words, my vector of a and b in the y direction. 15.3 plus negative 15.3 plus a positive 2.1 gets me negative 13.2. Okay, so now what this tells me is I've got my x, that's this part right here, and my y, that's this part right here, of my resultant vector, which is what I've been trying to find. But that doesn't tell me actually the length of my spot right here, my hypotenuse, we'll call it, and that doesn't tell me the angles. So that's what I'm doing next. I'm going to use my a squared plus b squared equals c squared. In other words, my a is this one, negative 18.5 squared, plus my b, that's that other negative 13.2 squared. Do you need the negative? No, certainly not, but we can put it in there because the squared will take care of it. And when I do that, I get 22.7 for my c. That is what I want. That's the magnitude of my resultant vector now. And now the last thing I need is my angle. So in other words, when I'm looking at mine, I've got x, or I've got y over here. That's my opposite. I've got x, that's my adjacent. And what I'm going to solve for is the angle right inside there. So the tangent of the theta that I want is the opposite, 13.2, over the adjacent, 18.5. I took out the negatives there because the calculator is probably not going to understand that so well. That gets me theta of 35.5 degrees. But again, that's not my full answer here. I need to do that all the way around kind of stuff. So I've got 180 plus the 35. So 180 plus the 35.5 to actually get me what my full vector is, 215.5. Now I finally got it. I've got my magnitude of my resulting vector, and I've got my angle. That would be this green thing right in here, all the way around to get it. Whew, did it. I think with these, you only get better if you do a lot of them, so this would be the one I would try. Hit pause here, write it down, and get it started on your own. And then I'm going to pick up from that and do it real quick for you. Again, I am low on time, so I'm going to talk pretty fast, but I think at this point you should kind of understand the different parts, and then you can kind of look at my answers more than listen to me, but I could be wrong on that. Okay, we're doing C plus D. So I've got my C here. It's looking at 45 degrees, which is right here, and it has a vector of 34 in magnitude. And I'm going to be adding it to my D, 123 degrees, which I'm going to say is right about here. And it's at 20 meters per second. So what I really want is this angle right here. That's 180 minus 123. 180 minus 123 is 57? 57, I think. 57 it is. 57. Gotta write better. And so I'm looking at my resultant vector here. So I'm going to add the two together. So here I've got C plus my D. And so the resultant is kind of a funny little one in there. He's like right in here, right? So I'm going to find this angle here, and I'm going to look at how much does it go x and how much does it go y. So let's set up our table, x, y. I'm going to look at my C vector and my D vector and take a look at my resultant vector as they add together. Okay, we'll start with my C here. In other words, I'm going in the x direction, so I want to know what's the C sub x. Well, there I'm looking at adjacent over hypotenuse, which is 34, and I know that's cosine. Cosine of 45 equals the adjacent, C of x, versus, or over my hypotenuse 34. When I get that, I get my C of x to equal 24.04. I'm doing the same thing with D. Once I've got this cosine here, I can just go the same thing. Cosine of 57 equals D sub x over the hypotenuse, which is 20 in this case. I can kind of follow my pattern, which gives me a D sub x of 10.9. Now what I didn't do when I did this math is look at, am I in a positive or negative direction? My C sub x is going in the positive direction, that's to the right, so I can keep it as a positive 24. But my D is moving in a negative direction, so I need a negative 10. So that way when I add positive 24 plus that negative 10, I get a 13.17, a positive value. Okay. moving here in the y direction. I'm going upward for both of them, which means it's going to be a positive value. It's looking at the opposite over the hypotenuse, so I'm looking at sine. Sine of 45 equals c sub y over that 34. So I get a c sub y of 24.04. And yeah, you're like, oh, that's the same number as the top. It is because it's at a 45 degrees. So it makes sense that both sides will be the same for a 45-degree triangle. Same pattern here, sine root of 57 equals my d sub y over its hypotenuse, which is 20. So I get a d sub y of 16.8. Both are in the positive direction as we talked about, so I just got to add them up, and I'll get a 40.84. And that kind of does make sense to have a big 40 there. It's going really high up here in the y direction, so that makes sense. Now I've got my over, this little arrow right here is at 13.17. I've got my up, that's at 40.84 in the blue, and now I can actually find my resultant. That's this deep looking blue stuff. So again, a squared plus b squared equals c squared. My a squared is at 13.17. It's all this resultant stuff. Plus my b, 40.84 squared equals c squared. If I do all the lovely math, I get c to be 42.9. And I've got part of it, so now I gotta get my angle. Here we're always going to be using tangent. I've got my opposite, 40, over my adjacent, 13. Up and down is my opposite, 13 is my adjacent. So I'm looking at tangent of theta equals 40.84 over 13.17. That gives me a theta of 72.1 degrees. And that does make sense to my 72. I like that number. It's going up right here. This angle does look like a 72-ish, so I got that. I got my magnitude, which is at 42.9, so I got it all.